Welcome to Quick Engineering. The topic of today's video is push down automata. So in this video we'll see what is push down automata, why there is need of push down automata, and what is the difference between push down automata and finite automata. So let us start with push down automata. Suppose there is language L is equal to A raised to n, B raised to n, where n is greater than equal to 1. So in this question, you will find there should be equal number of A and equal number of B. But if you try to solve this same question in finite automata, so you will find finite automata cannot recognize there should be equal number of A and equal number of B. The reason is finite automata does not have any memory mechanism so that it can remember the number of A and number of B. So to overcome this situation, there is push down automata. So what is the advantage of push down automata? Push down automata contains stack. So what happens whenever any symbol is read from the tape, the some symbol is inserted into stack, or it is removed, or there can be no operation. To ensure that there to ensure that the symbol has been read from the tape. So we will try to solve the same question from push down automata. So before that, we'll see the structure of push down automata. So push down automata contains tape. So tape contain input symbol, and there is finite control. Finite control contains head, which is used to read the symbol, and then there is stack. So this is the extra element which is present in push down automata and which is not present in finite automata. So what happens whenever this head reaches the any A, so here we have to ensure that there should be equal number of A and equal number of B. So in this case, what we will do, whenever we read A, we will insert something into the stack, and whenever we read B, so we will remove from the stack. So if the at the end, if the stack is empty, then we can say that there is equal number of A and equal number of B. So whenever I read A, I will insert a red plate into the stack. So this is the symbol. We can insert any plate. So we will insert a red plate. Then whenever we read next A, then again we'll insert next red plate. So stack pointer, this is called as stack pointer. So stack pointer will also get incremented. So whenever we insert the symbol, stack pointer gets incremented. Whenever we uh, remove the symbol, stack pointer will get decremented. So whenever we read next A, again stack pointer will be incremented. So this is how the symbol are inserted. Now whenever head will read B, so stack pointer will be decremented and red plate will be removed. Then for next B, again this red plate will be removed, and then for next B, again this red plate will be removed. At the end there is epsilon, so for epsilon we will remove this Z0 also. So at the end, if the stack is empty, then we can say that the symbol has been accepted, means string has been accepted. So this is how the push down automata work. The biggest advantage is it has stack, so that's why it is more powerful than finite automata. Now let us see the mathematical definition of push down automata. So it is defined by 7 tuple q sigma tau del q0 z0 f. Now what do you mean by capital Q? Capital Q is nothing but finite set of state. Sigma is a set of input symbol. Tau is a finite set of stack symbol. Here we use red plate, so stack symbol is R, and Z0. Del is transition function. Q0 is the initial state. Z0 is the initial stack symbol, and F is a set of final state. So this is how the push down automata is defined. In next video we will see some problem related to push down automata. So that's it for this video. If you like the video, please subscribe, like and share. Thank you.